Okay, good morning students. Today I am going to start a new topic named by conic section. Very important part for JE point of view. Last chapter we deal about a circle. Actually circle is also part of conic section only. Today I am going to explain a special type of conic sections like parabola and ellipse and hyperbola, etc. Circle also a part of conic section only. Okay, first of all I want to explain about cone and double napped cone and how they will generate. Here I want to explain the definition of a cone. Cone, everyone knows its shape. This is the cone, or sometimes called inverted cone. So base is in the shape of circle. So now I want to define the cone. This is a fixed ray. This is another ray but not fixed. This is called variable ray. Angle between these two rays are taken as theta. If theta is varying, automatically the position of variable ray will vary. That's why the ray is called variable ray. Now if this variable ray rotated with respect to this point in the space, so the figure so formed is called cone. So this is the cone. Cone is generated by rotating this variable ray with respect to this point. Okay, so this fixed ray is there, no? That is called height of the cone or called axis of the cone. So along this ray only the cone is formed. Okay, that's why this is called generator of the cone. Along this fixed point only the generated ray is rotated. Fixed point is called vertex of the cone. Okay, now if this axis is perpendicular to the base radius, then you can call this cone is right circular cone. Okay student, just now I explained how to generate a single cone in a space. Okay, now I want to explain how to generate double cone in a space. To define or to generate a double cone in a space, we need to take two straight lines, not rays, two straight lines. This straight line is called fixed straight line. Okay, so another straight line is taken, so that this straight line is called a variable straight line. So angle between these two straight lines is taken as theta. So if theta is varying, automatically variable line position will vary. So if variable line is rotated with respect to this point in a space, the figure formed is called double cone. I will show you and observe carefully. Okay students, here two lines are there. Here I can say this fixed line, I can call this is fixed line. So I can call this is variable line. So this is point of intersection of these two lines. Now observe. Variable line is rotating with respect to that fixed point which is indicated by red color. So what happened? So we got a double cone. Okay. So here this point is called vertex of the cone. The fixed point is called vertex of the cone. Okay students, so here we have two lines. This line is there, no? This is variable line, so I can call variable line as generated line, because through using that line only the cone is formed, no? That's why this line is called generator. And this line, fixed line, vertical line, is called axis of the cone. Observe the students, base is in the shape of circle. Okay, this is base radius of the cone. So another important thing is the axis should be perpendicular to the base radius. Then only you can call it is a right circular cone. So important thing, Nana, important. Base circumference is called directrix of the cone. Okay, directrix of the cone. Observe here students, this is the LSA of the cone, one of the cone, base cone, LSA of a cone, lateral surface of a cone, called nap. Yeah, so this blue color is called another nap. That's why a right circular cones, these two have two naps. That's why sometimes these are called double napped cone. Double napped cone. Double napped right circular cone. Okay, student, this is very important for us. The angle between generator and axis is called vertical angle of the cone. Vertical angle. Angle between generator and vertex is called vertical angle of the cone. Okay students, just now I explained about cone and double napped cone, how they generated. But our actual topic is conic sections. So conic means a cone. Section means to divide or to cut. So first of all I want to define the conic section. Okay. Conic sections are more simply conics are plane figures obtained by intersecting a plane with a right circular cone. Okay, now through one example I will explain this. So observe students. Yeah. Now this is the right circular double napped cone. So this is the axis of the cone. Okay, this is called axis of the cone, green one. And this is now just like a plane. See the definition. What is the definition? Figure formed by intersecting a plane with a right circular cone. Means you want cut this cone by using this plane. See here. So now I want cut the cone with the help of a plane. Here what I did, my plane is perpendicular to the axis, or my plane is parallel to the base of the circular cone. So in this case, the section formed by the cone is in the shape of circle. Okay, now we can call circle is the conic section when the cone is cut by a plane, so that the plane is perpendicular to the axis or parallel to the ground or parallel to the base of the cone. Okay, what happened in here? Angle is 90 degree. So angle between plane and the axis is 90 degree. So yeah, let the angle between axis and plane be beta. Means throughout this chapter, beta stands for angle between axis and the plane. Okay, similarly throughout this chapter, alpha is taken as the angle between generator and axis, that is called semi-vertical angle. So that I will write now. See, let alpha be the semi-vertical angle. Semi-vertical angle in the sense angle between generator and axis of the cone. So here what happened, in this case my beta equal to 90 degree. Okay students, if angle is 90 degree, that is beta is 90 degree, the conic section is a circle. If beta is varying, the conic section so generated will vary. Okay, sometimes it will generate parabola, sometimes ellipse, sometimes hyperbola. Is depend upon the value of beta. Students, now we are going to see an animation prepared by me. After watching the animation, you can understand how these conic sections are generated. I showed this is the three-dimensional space. Okay, the red line is taken as x-axis, green is taken as y-axis, and blue one is generally taken as z-axis. Okay, this is called three-dimensional space. So I want to explain all conic sections on this 3D plane using simple animations. Yeah, just now I explained how we will generate a cone by cutting a cone using a plane, so that plane parallel to the base of the cone or axis is parallel to the plane. Yeah, by my convenience I will use only single napped cone to explain all conic sections. Okay students, now I want to create a cone on this three-dimensional space. So first of all I want to draw a circle. So now I want make this circle into cylinder. Observe, so nice, no? So this is the cylinder in the three-dimensional space. Now I want make it into a cone. Observe students, what I am doing, I am shrinking the upper portion of the cylindrical cylinder, one of the upper portion of cylinder. So what happened, Anna? This will generate a cone. Yeah, this is the cone in 3D. So what I used, Nana? One napped cone on 3D. Observe the base. Okay, this is the cone on 3-dimensional space. So here blue line is acting just like the axis of the cone. Now I want make cross section of these 3 cone using a plane. Observe student, this blue one is a plane. Now with the help of this plane I will make cone into sections. Yes, students, observe here the plane is parallel to the ground. Observe students, I made at it. The figure so generated is a 2D geometrical figure which called circle. So that is the cross section of cone made by a plane when it is cut it in such a way that the plane is perpendicular to the axis gives a cone. Observe here the angle is 90 degree between plane and axis. Okay, yeah, this is circle. In this case our angle beta is equal to 90 degree. Also we can say that beta is greater than alpha, because alpha is the semi-vertical angle which is always less than 90 degree. So because generator and axis taken in this case are not perpendicular to one another. Okay students, now I want close this. Now I want change the angle between axis and now I want to change the angle between plane and axis. So here I am using protractor. Observe the students, this angle is beta is not equal to 90 degree. Observe the students, this angle beta is not 90 degree which is less than 90 degree. Observe students, this is one of the cross section of a cone. In this case 2D figure formed by cone is just like a ellipse. So the figure so generated is called ellipse. The important thing is here beta is greater than alpha. So in this case you can say that a figure so formed is called ellipse. So circle is the one of the special case of ellipse. There are also beta greater than alpha only, but beta equal to 90 degree. So here what is the alpha? Nana? Alpha is semi-vertical angle of the cone. Observe students, so I want close it. So this is the one of the conic section. This is ellipse. See, angle made by axis and plane is beta here. Okay, so now I want change the angle. I want take angle beta which is equal to alpha. Means that the plane should be parallel to generator. Observe here, the plane is parallel to generator. Now I want cut the cone by using this plane. Yeah, observe students, I want make a section. Yeah, observe. See, this cross section gives a two geometrical figure called a parabola. See the shape. This is the shape so generated 2D shape. So this shape is generally known as parabola. So in this case means beta equal to alpha case, the cross section of the cone is nothing but a parabola. Observe students. So this is 3D space, cross section of a cone with the condition alpha equal to beta. It is generates a parabola. See here, angle is beta. Again I want change the angle between axis and plane. Now angle beta is taken as which is lesser than the vertical angle alpha. Observe the students. Yeah, this is the cross section of the core made by a plane under condition beta lesser than alpha. This 2D figure so formed is generally known as hyperbola. Actually, to explain hyperbola, we need to take two napped cone. By using two napped cone only, you get exact shape of hyperbola. Okay, but my convenience, I used one napped cone. So using this one napped cone, I got one shape. So this is called one of the part of hyperbola. Actually, hyperbola consisting of two distinct parabolae. Actually, we want to take double napped cone to explain hyperbola. The cross section made by a plane so that angle beta is less than alpha will generate a two-dimensional figure called hyperbola, the combination of two distinct parabolae. Observe students, now I want to close this one. Okay, this is hyperbola, now the part of hyperbola. Yeah, okay students, now I want finalize. First one, circle. The conic section is circle when beta is equal to 90 degree. This is a special case of ellipse. Yeah, second one is ellipse. This is one of the cross section of the cone. In this case, beta is greater than alpha, and also beta should be less than 90 degree. So this is the shape of the ellipse. This is shape of the circle. Third one, Nana. Parabola. In this case, beta is equal to alpha. The last one is fourth one, hyperbola. Actually, we need to use double napped cone. So the angle between plane and axis is beta. If beta is less than alpha, that is semi-vertical angle, the cross section so formed is hyperbola. Okay students, now I am concluding. So observe here, my category is non-degenerated cones. So first of all, I want to explain what is meant by non-degenerated cones. The plane does not passes through the vertex of the double cone. Sometimes the cone will passes through vertex of the cone. Such situations, the conic sections so formed are called degenerate conic sections. But in what I explained previously, circle, ellipse, parabola, hyperbola, for all those conic sections, the plane is not passes through vertex. That's why these are known as non-degenerate conic sections. Among these, first one is circle. The plane figure obtained when the angle between axis and plane is a right angle. Means angle between axis and plane means here the angle is right angle. Yeah. Second one, students. Ellipse is the plane figure obtained when the angle between axis and plane is a greater than the semi-vertical angle. What is the meaning of this, Nana, here? Beta is greater than alpha. Okay. So already what is the beta, Nana, here? Beta should be less than 90 degree. So what happened? 90 degree greater than beta greater than alpha. In this case, the cross section obtained is called an ellipse. Okay students, third one, parabola. The plane figure obtained when the angle between generator and plane is equal, means beta is equal to alpha. So in this case, the figure obtained is nothing but a parabola. So last one, students, hyperbola. The plane figure obtained when the angle between axis and plane is less than the semi-vertical angle, means beta is lesser than alpha. So in this situation, the conic section so formed is nothing but hyperbola. Observe here, this is double napped cone. So this is one part of the hyperbola, this another part of the hyperbola, together like this, together gives the conic section which is called hyperbola under this condition. Okay students, now I want to explain about degenerated conic sections. The plane passes through the vertex of the double cone. The conic sections so formed are called degenerate conic sections. Actually, degenerate conic sections are point and a line and two intersecting lines. Okay, so one by one I will write none here. If plane passes through vertex ellipse becomes a point. Second one, if plane passes through vertex, the parabola becomes a line or a straight line. Third one, if plane passes through vertex, the hyperbola becomes two intersecting lines. Okay students, that's why this point and a line and two intersecting lines are called degenerating conic sections. Observe students, what happened? The plane is passing through vertex, then the ellipse becomes a point here. See, ellipse becomes a point. One will ask, what about circle? So circle is a special case of a ellipse only, no? Ellipse becomes a point means automatically circle also becomes a point only. Okay, in second case, the plane is passing through vertex of the cone. In this case, the parabola becomes a straight line. Okay, now third one, if plane is passing through vertex of the cone, the hyperbola becomes two intersecting lines. Observe here, this is one line and this is another line, two intersecting lines. So what happened? Hyperbola becomes two intersecting lines. Okay, Nana? Yeah, parabola becomes a straight line. Yeah, now ellipse becomes a dot. That's why point, line and intersecting lines also conic sections only, but special type of conic sections are we can call degenerate conic sections. So finally, what is conclusion? There are two types of conic sections. One is non-degenerated. Second one is degenerated. So here we have 4, here we have 3, totally 7 conic sections.